Suppose you own a business. You will definitely have a competitor who makes the same type of product that you sell. You need to make sure that your product is sold more than your competitor's product. To do so, you must compare your product with all the other products in the market. In such cases, Venn diagram holds useful to compare all the products. Venn diagram helps us to understand complex information easily. What Venn diagram does is, it helps us understand in what all aspects your product and your competitor's product differ, in what aspects they are both the same, what are the advantages of your product, and they also tell us where your product needs to improve. One thing to remember is that Venn diagram does not give solutions to your problem. Rather, it only helps us to visualize our problem so that we can make the right decisions. In this video, we shall learn in detail about Venn diagram. In our previous videos, we checked out what a set is and how it is useful for us in real life. You might already know, but let us recall the concepts we will be using here anyway. So, set is a collection of objects. Elements of a set may or may not be related to each other. There are three types to represent a set, and Venn diagram is one of the ways to represent a set. Universal set will differ from problem to problem. Also, a universal set is the set of all elements under consideration. To learn about these definitions in detail, check out the links of the previous videos which is given in the description box. In a Venn diagram, universal set is represented as a rectangle. Subsets are represented using circles. These subsets need not be represented as circles, but they just need to be represented as closed curves. Using the help of this example, we shall see how the Venn diagram changes with respect to the subsets. Consider the event of rolling a die. Then, universal set will be the set of all possible outcomes. That is 1, 2, 3, 4, 5 and 6. In problem number 1, the sets both A and B are subsets of the universal set U. That is because every element of A is in U and also every element of B is also in U. One point to note is that when universal set is under consideration, every other set will be a subset of U. So, all you have to do now is check whether set A and set B are subsets of each other. The elements 1 and 2 which are in set A are not in set B, and by definition, A can be a subset of B only if every element of set A is in set B. So from that we see that A is not a subset of B. In the same way, B cannot be a subset of A because both set A and set B have only one common element, that is 1. Also, elements which are not in set A and set B are in the universal set U. Keeping all these conditions in mind, let us now draw the Venn diagram. Let us draw a rectangle to represent the universal set U. Let us denote set A and set B by these two circles. Since these two sets have at least one element in common, we are going to intersect these two circles. Now, we have to place all the elements in these four regions. The elements of set U which are not present in both set A and set B will come under region 1. The elements of set U that are present only in set A will come under region 2. The elements of set U present only in set B will come in region 3. And finally, the elements present in all the three sets U, A and B will come in region 4. Since universal set contains all the elements, we shall sort all the elements in set U in the regions one element after the other. As element 1 is in all the three sets, it will fall under region 4. As element 2 is present only in set A and set U, it will fall under region 2. As elements 3 and 4 are present only in set B and set U, they will fall under region 3. As elements 5 and 6 are only in set U, they will fall under region 1. That's it. This is how we draw Venn diagram for problem 1. In problem number 2, the universal set remains the same, but only the elements of set A and set B are going to change. The elements of set A are 1, 3 and 5, and the elements of set B are 3 and 5. One thing to note here is that B is a subset of A. So there will be a small change in the Venn diagram, and that is, in the diagram, set B will be drawn inside of set A. And so the Venn diagram will now look like this. In problem number 3, elements of set A are 2, 4 and 6, and elements of set B are 3 and 5. In this case, set A and set B are disjoint sets. That is, set A and set B have not even one element common between them. So in the Venn diagram, set A and set B will not touch and be far apart from each other. And so the Venn diagram will look like this. In problem number 4, the elements of set A are 1, 3 and 5 and elements of set B are 2, 4 and 6. In this case, set A and set B are not just disjoint sets, but they are also exhaustive. That is, set A and set B are complements of each other. So, set A and set B together forms the universal set U. The Venn diagram will be drawn like this. Few more examples in this topic will be covered in another video. If you have found this video useful, please share it with your friends and family. Do express your views in the comment section. Do not forget to subscribe and like this video. Thank you.